Hi, my name is Megan McCarthy, and the deep dive that I chose to do was into fractions and fraction operations. The why I chose this topic, well, as a seventh grade teacher, I am supposed to be expanding upon students' knowledge of fractions by teaching them how to operate with positive and negative fractions. But over the last 6 years of teaching, I found that many students still struggle with the basics of fractions, and really understanding what a fraction is and kind of how it works. Um, and so I have chose this because I want my students to better understand it and be successful. After reading chapter 8 in our textbook, Teaching Student-Centered Mathematics, the reasons I found that fractions are so difficult for students to understand is because they can have many different meanings. They're written in a unique way when compared to other numbers. And after learning how to operate with whole numbers, that knowledge is generally over-applied to related fraction concepts. Um, and then lastly, my main reason for wanting to learn more about this is I wanted to find new strategies, models, and tools that I can use to help my students better understand fractions and fraction operations. I believe fractions are an important part of not only math but also life, and I want my students to be given the tools to be as successful as possible. On this slide here, you'll see the common fraction misconceptions found on page 117 of the Teaching Student-Centered Mathematics third edition for 6th through 8th grade. On this page, it gives these misconceptions as well as what it looks like, so kind of what teachers see that students are doing with these misconceptions, and then also giving ideas on how to help students overcome these misconceptions and better understand what they should be doing over what they are doing. But these are just some of the basics that are found in classrooms. The quote by Vanderwall, Day, Williams, Levin, and Karp in the 2018 third edition of Teaching Student-Centered Mathematics says the most effective way to help students reach higher levels of understanding is to use multiple representations, encourage multiple approaches, and elicit explanations and justifications. I thought this quote was really fitting, not only just for the fractions part of things, but also just um, math in general, because these are ways and things that we should be using in our classrooms to help our students better understand any and all math topics and not just fractions. Helps our students reach a higher understanding of anything. And then two of these three ways are two of the teaching strategies that I've chosen to discuss in the latter of my PowerPoint here. My first teaching strategy that I wanted to share was the use of multiple representation models. I personally think this is the most important of all of them, just because a lot of students are very visual learners. They like to see things, they like to have pictures. So I think being able to show models is great. I also have found that substantial evidence suggests that the use of visuals in fraction tasks and other math topics helps students understand better. So these are great ways to learn. The first one in the top right hand corner is the area model. It's based on how a part of an area relates to the whole area. You can see some examples there, as well as an example of what it looks like. I really like this example because I think a lot of the time we see circular models, whereas this one is showing us a rectangular model, and I think that's great because you don't see that as often. On the left-hand side, you see the set model. It's based on how many discrete items are in a whole set and how many items are in the part. A lot of the times we see this discussed as how many students are in a class and compare like boys to whole and boys to girls, girls to boys, that kind of thing. But you can also set it up again with a picture of how many things are within a set and then discuss that in a fractional way. And then the third one in the bottom right hand corner is the length model. It's represented as a distance on a paper strip or a number line. One thing that constantly came up in my research and in the book is that number lines need to be continuously used throughout mathematics. I think we tend to drop it off of our tool list in the beginning. I personally think that we drop it off in seventh grade after we teach integer operations. But they discussed in all of my research that uh, number lines should be used extensively. They're a very great tool to help with a lot of different types of mathematical operations. So that was kind of interesting to me. But those are your three representation models: area, length, and set. Um, I also found that the use of multiple visuals to represent one problem helps students to build not only a conceptual understanding, but it also helps them to decide for themselves which representation is best for any given situation, which is a really important part of math, is just being able to understand a problem and decide what is the best way to approach this. So I thought that was really awesome. My next teaching strategy is to provide context. Um, when we provide context, that would be like giving a word problem. Word problems help students make sense of the numbers before having to formally work with them in a mathematical sense. Um, it also gives problem context. Giving a problem context allows students to connect real life to the math to better understand the situation. I found in the past that if you can connect the math to something that the students have experienced in their own life, they better understand it, and it helps them to just better be able to dive right into the problem. Providing context also allows students to invent strategies that can eventually be connected to the standard algorithm. That's another thing, is we need to allow them to invent their own strategies to solve problems, because then that gives them more opportunities of finding new ways to solve problems, as well as getting themselves to the standard algorithm instead of us just telling them that algorithm. And lastly, it provides students with which manipulative or tool to use in order to solve the problem. For example, with the manipulatives, when we give them context, if like we're talking about a round shape such as pizza, pie, a quesadilla, then we would use the circular area model. That would be the best tool for that one. But if the context then is distance, then we would want to use a paper strip or a number line as the best tool. Again, providing context is not only going to give them the opportunity to connect to the problem, but it's also going to give them the opportunity to decide what is the best way to solve that problem. My third teaching strategy, I felt as though instead of bullet points, that this quote from chapter 2 of our book, Teaching Student-Centered Mathematics, is the best way to kind of describe how we allow students to explain and justify, or why we allow students to explain and justify. The value of student talk throughout a mathematics lesson cannot be overemphasized. As students describe and evaluate solutions to tasks, share approaches, and make conjectures, learning will occur in ways that are otherwise unlikely to take place. Questions such as those that ask students whether they would do it differently next time, which strategy made sense to them, and what caused problems for them are critical in developing mathematically proficient students. As they listen to other students' ideas, they come to see the varied approaches and how problems can be solved, and see mathematics as something that they can do. For students, by explaining how they did something or why a particular method works, they're developing their adaptive reasoning, and can begin to reflect on their strategies and decide for themselves what mistakes they may have made, or possible shortcuts that they may have found that are leading them into those algorithms. Just by discussing with the teacher, the class, by also allowing students to explain and justify, the teacher is able to determine if students are using valid methods to find their solutions, and can determine which strategies should be shared publicly with the whole class, just so everyone is learning different strategies and ways of doing problems. So allowing students to explain and justify is another great strategy. How I hope to apply what I have learned here. I want to begin by emphasizing numbers into my classroom, just because if students aren't understanding fractions, there's other topics in math they also may not be understanding. And I think if we can focus on the actual meanings of fractions and numbers, instead of the procedures and algorithms for manipulating them, more students will be successful in math, and more will be willing to try new things without having the pushback of not being a math person. I also, a few things that stuck out to me that I would like to use throughout or not just fractions, but throughout multiple topics, is always provide a variety of models and contexts. Again, that was my first and second strategy. Make extensive use of number lines. I really, that one really hit home. I feel like we stopped using number lines after a while, and they need to be continued to use, because I think students, they really understand them because they get so much use with them. And encourage estimation. That was another thing that got brought up quite a bit. Just didn't seem as important to me as some of these other strategies, but that was another strategy that you could use, is estimation. At first, I thought some of these ideas were a little elementary, using number lines, estimation, providing visuals and context and models. But now that after all my research, I can see that no matter what age or level students are at, all of them will benefit. And the main idea that I hope to apply to my classroom is the explanation and justification. This is something that came up in all of my research, but allowing students to explain and justify their reasoning, they're able to see mistakes they made and discover an easier, or maybe even discover an easier path. Sometimes I just feel like we rush through teaching, and we rush through it and don't give students the time to actually explain what they're doing, and we just sit there and say, no, you did this wrong. And I really think that allowing them that opportunity is going to really make a huge difference in the classroom, giving them the opportunity to talk and discuss and explain things. And here we have the three sources. We have the textbook, and then I have two different articles of mathematics